Yeah, welcome to the JAMB CBT Chemistry class, part 1. Welcome to JAMB CBT Chemistry class, part 1. You follow us on this part 1, you will get part 2, part 3 to the end of the whole class. Then remember to subscribe. Your subscription is necessary so that whenever we post class 2 questions and teaching on the class 2, you'll be able to get information about it. So can we go to the question we have? The distance between the nuclei chlorine atoms in a chlorine molecules is 0.194 nano. This N stands for nanometer. Nanometer. Full stop. The atomic radius of chlorine atom is dash. This is 9. Okay? Then I said option A give us this, says 0.097 nanometer. Option B says 0.914 nanometer. C says 0.388 nanometer. D said 2.388 nanometer. We now say solution. Atomic radius of a solid. Remember that atomic radius of a solid element, because we cannot talk about radius of what gaseous what element. It's a solid element, we can get the word radius. We said atomic radius of a solid element is half the distance between the two adjacent nuclei. You will now see the diagram I put here. This is an atom, this is another atom. Look at the nucleus of this atom. Look at the nucleus of this atom. The distance between this nucleus and this nucleus of this atom that touches each other. You see that these atoms touches themselves. They must touch themselves, not atom that is far from each other. We will begin to talk about the radius between them. No, we talk about atom that touch each other. That's when we begin to talk about their radius. We said this atom and this atom touch themselves here, and this is nucleus of this atom. This is the nucleus of this atom. The distance between the two nucleus is what they give me here. They said the distance between the nuclei chlorine atoms in a chlorine molecules is what this. This is the chlorine molecules. When we talk about chlorine molecules, we say Cl2. This is chlorine molecule. Why I have Cl as chlorine what element? Why this is a chlorine molecules? This is a chlorine what atom or element. Then the distance between the two molecules, the two what molecules nucleus, the two molecules nucleus is what 0.194. Then now we say that. Then I remember that R, which is the radius, atomic radius, is the distance between the nucleus and what outer shell. Then distance between the nucleus and outer shell. This is from nucleus to outer shell give me the radius of an atom. That means the radius is from here to here. Then I will now say atomic radius R is equals to the distance between the two nucleus divided by 2. If I divide the distance into 2, I'll get the radius, which from here to here, which is the radius. And I say this divided by 2, I now have that R is equals to, come down here, if I divide 1 by 2, it cannot go. I will put 0.0. Then I will now say divide 19 by 2. Look at this is 19. I take this one and add to this, give me 19. Dividing 19 by 2, I will have 9. Remainder 1. Putting 1 here, give me 14. Dividing it will give me 7. So you will now see, come over here, you see that when I divide this 1 by 2, it will give me 0. This is 0 point. This is 0 point. Divide it will give me 0. Divide this 2 by 19 will give me 9. I carry 1. Remember 1. I carry 1, put here, give me 14. Divide it will give me 7. Therefore, I have this as my nanometer. I want to go to my option. Look at our option. I see that option A, which is 97 nanometer, 0.97 nanometer is the answer. I would say the answer is option A. The noble gas argon is used for dash. A. Electric arc welding. This is electric arc welding. B. Welding brass. C. Underwater welding. D. Steel welding. We say solution. What they ask us here is that the noble gas argon, that is the noble gas, which is argon, is used for electric arc welding, welding brass, underwater welding, or steel welding. Solution. But remember, before we go into solution of this, remember to subscribe to this world channel for more educational video on JAMB chemistry. Now let's go to question. We say solution. The elements in a group O, are known as rare gas or noble gas. They have no bonding electron in their outermost shell. They have no bonding electron in their outermost shell. Hence, the group is named 0. You have seen why we have group 1 to 0. Group 1, group 2, group 3, group 4, group 5, group 6, group 7, group what? 8, which we call group what? 0. Why? Why do we call it group 0? Because it has no what? It has no bonding electron in the outermost shell. There's no electron to give out. The whole electron have used to form otate state. That's the reason why we call it group what? 0. Then shell. Hence, the group is named 0 as the total number of electrons in outermost shell of element tells us the group it belongs to. Are you getting what I'm saying? The total number of electrons in the atmosphere tells us the group it belongs to. Then you now say the noble gases include, let us see the noble gases. The noble gases include helium, neon, argon, krypton, xenon, and the radon. Are you going to see xenon and what? Radon. These are, they are, 1, 2, 3, 4, 5, 6, which are what? Noble gas. And we have seen them. We say preparation. How do we prepare noble gas? We said preparation of noble gas. The noble gases occurred in the atmosphere, although their relative abundance are very low as monoatomic. What do you mean by monatomic? Single atom. They don't come into what? Diatomic. They are in a what? Monoatomic, means they are coming in single elements. Monatomic molecules in the atmosphere, they constitute about 1% of the composition of air. The composition of air is composition of air contain about 1% of what? Noble gas. That's what we are trying to say here. But now, how do we prepare noble gas? Because we preparation. We say noble gases are extracted from atmosphere. Noble gases are extracted from what? Atmosphere by the fractional distillation of liquefied air. Fractional liquidation of what? Liquefied air. We said fractional distillation of liquefied air. That's where we what? Obtain the what? Noble gases. Noble gases are obtained from air because air contains noble gases. Then physical properties. We come to physical properties. We say number 1, they occur as colorless monoatomic gases with little tendency to combine with other elements. That means they are inert. They don't have eager to react. They are reluctant to react because they are in their otate state. Most of what? Noble gases are in their what? Otate state. They are in a suitable state. So they don't have that eager to what? Go into reaction. We say number 2, the only forces of attraction, bonds, forces of attraction, or we call it bonds, among the atoms of noble gases in the liquid and the solid state are weak London or Van der Waals forces. We call it Van der Waals forces. That's a weak bond. That's connect the neighbor of the water noble gases. So that means the intermolecular forces are weak. The intermolecular forces are weak. They are far from each other. So we said that among them atoms are what? Noble gases. In the liquid are weak. We have weak London or van der Waals forces. These two forces are the same. We say number 3. Noble gases have low melting and what? Melting point and boiling point. Due to their weak bond, they have low melting and boiling point due to their what? Weak bond. Reason why are they having low melting and boiling point? Because they have what? Weak bond, which we call London, where weak London or what? Van der Waals what? Forces of what? Attraction. Their intermolecular forces are weak. Therefore, they are what? They have low melting and a boiling what? Point. They will not say their weak bond, which we call weak forces of what? Attraction, contribute to their low bond, boiling and what? Melting what? Point. 4. Each noble gas has the highest ionization energy potential of any element in the period. That means each of the noble gas has highest what? Ionization energy compared to any other element in that what? In that word period. So we now said, what is ionization energy? For the first time, what do we mean by ionization potential or energy? We said ionization potential or ionization energy is the energy required to what? Take away an electron from what? Metallic what? Element. It's only metallic element that undergoes what? Ionization energy, because that's the energy required to take electron. Take what? One electron from that what? Element. To borrow one electron from him. So, when I say that what? Ionization energy or first ionization energy is less than second ionization energy. What does it mean? The first ionization energy of an element is less than the second ionization energy of that the same what? Element. For instance now, if an element is about to give 2 electrons, the energy required to what? For him to give you 1 electron is less than the energy it requires for you to come the second time to take the second what? Electron. For instance, if we have what? Calcium and sodium. Sodium require what? Is a 1 electron, that's which it can give out. But we come to calcium. Calcium is going to give out what? 2 electrons. So for the calcium to give the first electron, for him to give the first electron, the ionization energy required for him to give this first electron is less than the ionization energy required for him to give the second electron. Just like when you beg your friend something for the first time, he will give you freely because you are friend. If you come the second time, he's going to question you, what of the one I gave you before, where do you keep it? Just like as this what I'm saying now. So you say the first ionization energy is always less than the second ionization energy of what? Metallic what? Element. Then now we go back to say what here they said the ionization potential decreased from what? Helium to what? Random as expected because of their increasing atomic size. As the atomic size of what? An element increase, therefore the ionization energy what? It decreases. We said as the atomic size increases, therefore the what? Ionization energy what? Decreases. And look at the order of decreasing of what? Ionization energy. He said he decreases from what? Helium to what? Radium. When I said helium is greater than what? Neon, and neon is greater than what? Ionization energy of helium is greater than the ionization energy of what? Neon, and the ionization energy of neon is greater than the ionization of what? Argon, and the ionization energy of argon is greater than the ionization energy of what? Krypton, and the ionization energy of krypton is greater than the ionization energy of what? Xenon, and the ionization energy of xenon is greater than the ionization energy of radium. So this is order of decrease. Order of the decrease of ionization energy. Chemical properties. We said xenon reacts with what? Powerful oxidation agents, which we call platinum hexafluoride. Platinum hexafluoride is a powerful what? Oxidation what? Agent. When you react with what? Xenon, you will now give us this what? Xenon fluoride, 4 and xenon. This one, xenon fluoride is going to be what we call what xenon, what fluoride. That's what the reaction that will go. And that's the only reaction that goes with what? Noble gases. So when I said noble gases undergo this reaction with what? Xenon, the only xenon that undergoes this reaction to give us this chemical what? Property. We come to what? Uses of noble gases. Uses of noble gases. They will say helium. The helium, which will say the gas, is used for what? Filling observation what? Balloons. Observation balloons. What we call observation balloons? Balloons that we use to what? In our playing ground. You will see the balloons what? Rising up and what? Going into the air because his leg denser than what? Air. We said you use it to what? Observation what? Balloons. Observation balloons. And other lighting than aircraft. Other what? And other lighter than aircraft. It will be lighter than aircraft when we use what? Helium to what? Fill what? A balloon. It will be lighter than aircraft and it started flying up without what? Adsorption. So we said again, it is now a replacement for what? Hydrogen. This is hydrogen we used to do it before. We use hydrogen to what? Fill the what? Balloon for this observation. Then but now helium take the position of what? Hydrogen. Why? Which was previously what? Used because helium does not burn. Why did helium take the position? Helium does not what? Burn. Therefore, it takes the position of what? Hydrogen, which also what? Burn. But helium does not what? Burn. Although helium is about twice as denser as hydrogen, so it's denser than hydrogen. But what made him to take the position of hydrogen? Second property that made helium to take the position of hydrogen, we said, but helium has a lifting power that is 92.6% than that of hydrogen. That's the second what property that made him to knock hydrogen away in filling what? Observation what? Balloon. You say that helium does not burn. That's one of the things that makes him to be what? Used instead of hydrogen to fill what? Observation balloon. Second, helium has what we call what? Lifting power than what? Hydrogen. So we now say note. Let us know what we mean by lifting power. We say note that what? The lifting power of a gas less than the air is determined by the differences between what? Its mass and that of the unequal volume of what? Air. That's when we get an equal volume of air and the mass of what? Any what? Noble gas. We'll compare it. By the time we compare it, if it's less than that, that means it can what? Fly in the what? Air. That's what we call lifting power. We say the lifting power of a gas less than that air. Before it can be what? Lifting power, it will be more less than what? Air, what density. We say lifting power of a gas less dense than air is determined by the differences between its what? Mass and that of what? An equal volume of what? Air. Then we say to second what? The second uses. We said mixture of helium and oxygen are used in the treatment of what? Some respiratory disease such as what? Asthma. So we say that we use helium to what? Heal an asthmatic what? Patients in hospital. The reason why do we use that? Reason due to lightness of helium compared to nitrogen. We say that helium is more lighter than what? Nitrogen. Instead of using nitrogen, we use what? Helium. And the rapid diffusion lowers the muscular what? Energy required for the what? Breathing of that what? Patient. You see that what? This is what made what? Helium to be used as what? Treatment of what? Asthmatic, because it's more lighter than what? Nitrogen. Property 3. Because of its inertness, helium is used to maintain an inert atmosphere from melting and welding readily oxidizable materials. We now use this we use helium to what? Protect the easily what? Oxidizable what? material that we want to wear so that it will not explode. We use what? Helium to what? Maintain the what? A good atmosphere, because helium is a what? An inert, so it cannot react. So he keep the what? Atmosphere what? Dormant, so that you can be able to wear that readily oxidizable material. And for other chemical process, in other chemical process that can easily what? Explode or have explosion due to what? Air, we use helium to what? Nullify the explosion. Number 4, we say liquid helium is used to maintain very low temperature. You see it again. We use liquid helium to maintain what? Very low temperature, because of its what? Extremely low melting point. You know, is the one that have the highest what? The lowest melting point compared to other, as it has the lowest what? Ionization energy. According to what we have done, we see that helium is the one that has what? The lowest ionization energy. Therefore, he has a what the property that keep him what? The temperature to be what? Maintain very, very low temperature. So if we have to maintain a low temperature, we can pump helium to what? Maintain that low temperature for us, because of it what? Extremely low melting point. That's why we can use it to what? Maintain a low temperature. Then we use helium to maintain a low temperature. Note it. Then number 5, liquid helium is also used as heat transfer medium for what? Nuclear reaction. You know that the nuclear reaction has, for a nuclear reaction to occur, there will be heavy heat. Heavy heat. As nuclear reaction is occurring, there is a heavy heat. So we now use a liquid helium to what? They reduce those what? Heat. We now pump liquid helium to what? Extract what? The heat away, so that our reaction or the material which we use to carry on the what? The nuclear reaction will not burn. You know that we have a material which we use to carry that what? Nuclear reaction. For that material not to burn, we now use helium to reduce the quantity of what? Heat that will be generated as a result of what? The nuclear what? Reaction. Just like what we said, number 4 is used to what? Maintain low temperature. That attribute is what applied here in the nuclear reaction. We come to neon. Neon, number 1, is mainly used in neon lamp and also sign. You know that we have halogen lamp. That halogen lamp is what we use what? Neon to what? Maintain that lamp so that it will not what? Ionize. So also, we now come number 2, is used for what? Cooling radiation detector. Radiation detector. We know that we have a radiation detector in our nuclear reaction what? Chamber. We have a radiator detector which we use to detect what? The radiation, the rate of radiation. So we now use this man, which we call what? Neon, to what? Cool it. Just like in a refrigerator, we have what we call ammonia as our what? Refrigerating what? Cooling agent. We now come here and say, because of its higher refrigerating capacity, you use it to cool the what? The radiation detector. Then argon. Argon, we said, let me look at it now. Argon, number 1, is used for filling light bulb. And which we call, what's that light bulb? Light what bulb? What's light bulb? Tungsten what bulb? You know, say we have 2 types of lighting bulb. We have halogen bulb. We have tungsten bulb. This tungsten bulb make use of what we call constanta, which we use to, when you pass a current on it, it will generate heat, which will give a light. So for that constanta not to what? Burn, we now use argon to maintain its what? Oxidation, so that it will not what? Oxidize and burn. So we now said it's used for filling the light bulb, which we call what? Tungsten bulb filament, which will be always red in color, and in the what we call what? Metallurgical what? Operation. In metallurgical operation, when we are what? Using what? Blacksmith. When we say metallurgical operation, in a blacksmith process where we what? Shape what? Metal, we can use argon to maintain is what? The operation we needed to do. So now the second use of argon, we said argon is used for electric arc welding due to its inertness. To maintain, what do we use it to do? To maintain an inert atmosphere for welding and what? Welding for what? Melting and welding what? Readily what? Oxidizable material. You will not see that the function of argon is having, when this function of argon, also helium has the same function. We use it to maintain the atmosphere for welding material that is what? Easily to what? Oxidize and cause what? Explosion. So we now bring what? Argon to make that environment to be what? Cool, for no what? Or what? Explosion will what? Occur. To subdue the explosion, we use what? Argon to reduce, because it's an inertness. So this is not what? That is property of what? Inertness that was giving him this. So we said it's used for electric arc welding due to its inertness to maintain an inert atmosphere for melting and welding readily oxidizable material. We come to what? Xenon. Xenon is used in conjunction with what? Krypton in high intensity short explosive photographic what? Flash tube. Photographic flash tube, we use what? Xenon here. Then we have krypton. Krypton is used in a what? Airport, running way, run what way and what? Approach light. You know that in a what? In a airport, we have a light that we use to indicate to what plane when it's landing and when it's going up. So that light is filled up with what? Krypton, because it gives a longer life to the what? The light bulb. So any light we will use a krypton, that to halogen light, halogen bulb, which we use krypton to what? Protect, we have a longer life compared to the one that is using what? Argon. So we now say because it gives a longer life to the what? The light bulb, although it is more expensive than argon. Have you seen it now? So you will now see that those bulbs you see in the what? In the airport, those bulb lighting indicator in the airport is filled up with what? Krypton, and is more expensive compared to the one we use what? Argon. Because argon is used to what? Fill as well. We now say again, the second man is what we call radon. Radon is used in the radiotherapy of cancer because of its radiative what? Nature. It has a radiative nature, therefore we use it in the radiotherapy of what? Cancer, which is radon. Now, back to our question. Our question said the noble gas. Then they mention noble gas in this question, but they single out argon. Have you seen the reason why we go into naming their uses and their characteristics and their properties and chemicals? So that's the reason why we're going to learn their what? Characteristics, uses, and properties. You see that they mention the noble gas, but the single out argon is used for what? Dash, which is an electric arc welding brass, underwater, steel welding. You now see from what we have learned now, we find out that what? Argon is used for electric arc welding. It's used for electric what? Arc welding. You remember that it's not only argon used for that electrical arc welding, that helium as well is used on that what? Process. So you remember what we learned here. So automatically by looking at it, our option here become what? Answer. Our answer here is become what? Option what? A. Option A is our correct what? Answer. How many grams of bromine will saturated 5.2 gram of boots 1 in 3 I? Boot 1 in 3 I. This is 3 I. 3 what? I. Boot 1 in 3 I. They said, how many grams of bromine will saturated 5.2 gram of boot 1 in 3 I? They said option A, option B, option C, option D. Remember, your subscription is very necessary for us so that at any time we post a new video, both in our class and the JAMB question and answer, you will receive them. So now, looking at this, this C is what? H is 1, and bromine is 80. That's what they give to us. Solution. I remember the first thing I would do is to draw. What am I going to draw? Boot 1 in 3I. I want to draw it. How many carbon? The parent's name is what? Boot, which is 4 carbon. I have C, and I have C again, I have C again, and I have C. That boot. Then boot 1 means that the functional group of what? In, which is what? Alkene, in, is in what? Carbon number 1. It means that what? The functional group in, which is double bond, is in carbon number 1. I may start it for this, making this one what? Carbon number 1. And this one telling me that what? 3I, functional group of what? Alkyl, is in what? Number 3. Carbon number 3, which is the functional group of alkyl. Functional group of alkyl is triple bond. That means that triple bond is the carbon number 3. Since I have choose this one to be my carbon number 1, so this one will now be what? Carbon number 3, which is what? 1, 2, 3. That's the bond. Then I have to complete the rest with hydrogen. Now this is the first thing I check. I take this one to be my carbon number 1. I call it number 1. This one become number 2, and this is number 3, and this is number 4. Are you get what I'm saying? So this one telling me that what? The functional group of what? A is a what? Function carbon number what? 1. While this one is telling me that the functional group of what? I, which is what? Triple bond, is carbon number 3. So before I can know the carbon number 3, I have to choose carbon number 1, which indicates my starting point. Then the next, I will pull this to the what? This, which is this one is complete. I will pull this one to the 1 again. This one is complete right now. I will have this as my hydrogen. Here, this carbon is what? Completed. And this one needed 1 carbon. I will have this to be what? There. This is what? The name is what? Boot. The name is what? Boot 1 in 3 I. That's the name. Then now, what they ask me is how many bromine will I use to saturate? You know that this unsaturated hydrocarbon, two unsaturated hydrocarbon, which is what? Alkyl and what? Alkene and alkyl. So now, for me to saturate them, they said how many bromine? Then looking at this man, he has a double bond. For me to remove this one single bond here, I needed 2 bromine. You know, for me to remove 1 bond here, I needed what? 2 bromine. Then for me to remove the 2 of the bond here, I needed 4 bromine. So that means 2 for this one, 2 for this one, giving me what? 4. 2 for this one, giving me what? 6. That means I needed 6 bromine. So for me to saturate this man, I have to what? Bring what? 3 bromo, which is bromine. This time, this give me what? 6. 2, 2, 2, which is 6. Then that will now offer me, will give me, what is going to give me now? He give me this, which this one now, one will go for this. I will have this. I will have, let me draw it proper. This will land me to here. I will have this to be what? Bromine, giving me this. And this one will be my H. This will be my H, and this one will give me what? Bromine. H. This will give me bromine, and this will give me what? Bromine. 1, bromine, and here will be what? Bromine. And here will be also what? Here will be what? Bromine. Here will be bromine. Here will be what? Bromine. And here will be what? Bromine. What do you see now? You see how many bromine? 1, 2, 3, 4, 5, 6. Okay, here is what? Hydrogen. I mean to say. I'm now counting now. How many now? 1, 2, 3, 4, 5, 6. And how many hydrogen? 1, 2, 3, 4. 1, 2, 3, 4. That's the 4 hydrogen. Then how many bromine now? 1, 2, 3, 4, 5, 6. Now look at it. How many hydrogen? 1, 2, 3, 4. So you now see this is what we needed. Then therefore, what they now ask me, how many bromine will saturate this? That's this number of bromine. But look at it, they asked me in gram, which is 5.2 gram of what? Of the what? Bromine. So now I cannot say that this man now which I have here, how many carbon it is? I'll write this man as what? C4H what? 4. C4H4, that's this man, will give me what? 3 bromine. Are you get what I'm saying now? Then therefore, how many gram of this man is here? I'll have how many? I'll have 4 carbon times what they give me as carbon, which is what? 12 plus 4 hydrogen times what? What they give me as hydrogen as 1, and that's a gram. And this will give me, coming here, this will give me 3. This times this will give me 3 times what? 2 times 3 or 2 or 3 times 2, anyone. Then times what's the mass of the bromine? Mass of the bromine they give me is what? 80. Look at it, and now write 80. Are you following now? And that's will give me what? Gram. That's this is in gram. That implies this time this will give me what? 48. 48 plus what? 4. That's give me the gram. And is equals to, this will give me what? 6 times what? 80 gram. Are you what I'm saying? That implies, can I finish it here? We come over here, I said, come here, 48 plus what? 4 will give me 52. 52 gram of what? Boots. 1 in I will give me, will be saturated with what? 6 times 80 gram. Then what will 5.2 gram of what? But this we do. If this man can give me this, then what will 5.2 gram will what? Give me, which is a question mark in gram. This man, according to my equation, according to my reaction, this man will give me what? This will give me this, according to my reaction. And that's my reference point. According to the reaction, this 52 gram of what? Put 1 in 3I will be saturated with what? 6 times 80 gram of what? Bromine. Then what will it? 5, look at here, what will what? 5.2 gram of what? The same put 1 in 3I will be saturated. We will be what? Saturated with what? The bromine. I cannot say my reference point always divide. I will now have 5.2 divided by what? 52 times 6 times 80. Then I will have that this implies that the same thing as what? This is something as what? 5.2 times 6 times what? 80 all over what? 52. Then let's see fraction here. Look at the fraction I'm seeing here, 5.2. For me to clear this fraction, I have to multiply down and up by what? 10. I will have that this is same thing. This implies that what? 5.2 times what? 6 times what? 80 all over what? 52 can be times by 1, 10 all over what? 10. And when I do that, I will have this to be what? I will have this to be what? 52 as well, times what? 6, times what? 80, all over what? 52, times what? 10. You remember that JAMB doesn't give calculator, and that's what I'm doing this. Then this will kill this now, destroy this. I will now have what here to be remaining what? 10 will divide this will give me what? 8. I will now have that what? 6 times what? 8. 6 times 8, I will have what? That what? 6 times 8 will give me 48. That will give me what? 48. Because 3 times 8 will give me what? 24. Therefore, 6 times 8 will give me 48 gram. That means that 48 gram of what? Bromine will be used to saturate 5.2 gram of what? But 1 in 3I. That means 48 gram of bromine will be used to saturate 5.2 gram of what? Put 1 in 3I. As we know in our reference point that 52 gram of what? 6 times 80 gram of what? Bromine will be used to saturate what? 52 gram of water bromine put 1 in I. So let us go to our option. This is 48. I go to my option. I have option A. 64, option B 48, and that's my what answer. I will say my answer is what 48.0 gram. That is our answer.